Okay, everyone. Well, welcome to our annual Midwest DevFest. We're excited to have you all here and join. Let me share my screen and we can start going through the slides, and then I will introduce Dawn shortly. All right, so hopefully everyone can see everything just fine. All right, so here we go. Welcome everyone for our annual 2020 Midwest DevFest. We have a lot of organizers who have helped us in the past month and a half put it together, so we're excited to kind of get things kicked off. So, all right. These are our 5 presenters today. We have Jennifer, Martin, Kyle, Victoria, and Dawn, who will be sharing you all the latest developments in technology. So yes, our first up speaker is going to be Dawn. But first, before we get into our first speaker, there are some etiquette rules to kind of go over first. So right now we are using Remo, which is a video conference platform, but one thing that we do ask you to do is to turn on your video camera, and that way it will encourage more face-to-face interactions. Also keep your microphone muted if it is on. That way we can make sure that we hear Dawn when he gives his presentation. The other thing we'd like to note is to be excellent to each other. When you're chatting or networking, there is a code of conduct site that you can visit, as well as a video to kind of go over that. The other thing is we'd like you to fill out our speaker and attendee feedback form. This way we can kind of improve like future talks for meetups or DevFests for next year. And then when you do fill that out, you will actually be entered into a raffle to win a really awesome prize. One of them is actually a Google Home Mini. So you should definitely take advantage of that. Also, if you do have questions, make sure you use the remote chat box that's off to the right-hand side. You can also socialize and network as well in that chat box during the presentation of all of our speakers. But once that is over with and we go back to our tables, you can actually interact with people there. So each table that we have in Remo is set up by topics. So if you're interested in Firebase or just want to talk about work life, feel free to head over to any of those tables in between breaks to chat with people. If you do want to see the speaker schedule, there is a link that you can click on here. We should be able to share this slide deck in the chat box so you guys can kind of like follow along with us. But we do want to let you know ahead of time that there might be some technical or personal interruptions, so just be aware of that. All right, so briefly, this is the agenda for today. So as you can see, from 12:10 to 12:55, we have Dawn, who's going to be talking about AI in the palm of your hand. The next speaker at 1 is going to be Victoria Gonda, talking about internationalization. At 1:30, we have Jennifer, who's going to go over that there are no snow days when you work remote, which I'm sure a lot of us are experiencing now that we're working from home. The next speaker is Martin, and he will be going over growing your cloud application. The next one at 3:30 is going to be Kyle Paul, who will be talking about serverless applications with Firebase. And then at the very end, we'll have surveys, raffle, and closing remarks. If you want to socialize at any of the tables for the last 20 minutes, feel free to do so. We'll be there too at the very end, so you should talk to one of us if you'd like. All right, as you can see, these are all the organizers, part of the Midwest DevFest. So we really want to thank them for coming together and putting this event together, because without them, this would not be possible. So sincerely grateful to have them participate and help us put this on. All right. And then next, our sponsor is Inspire 11. Again, we want to thank them for their support because without that, we wouldn't be able to host. If you want to know a little bit about Inspire 11, they are a full-service digital and analytics consulting firm that is based in Chicago. And also, FYI, they are hiring. So if you want to take a look at their website and see what they're about, you can click in on the link that we have up here, as well as a little video that kind of goes into what their organization is about. And you can also, if you would like, follow them on LinkedIn and Facebook for any cool updates. So thank you, Inspire 11. All right, so we are going to introduce Don Ward, who is a senior software engineer at Quicken Loans. It's one of the nation's largest mortgage lender that is based in Detroit, Michigan. He's basically been building mobile apps for, I would say, the past 10 years. He also entered and won the 24-hour hackathon that leveraged the power of the Apple Watch. If you want to follow Don, you can follow him at his Twitter account, Don Ward PNG. So anyway, that's a little bit about Don, and I will hand it off to him. So welcome, Don. Thank you.
Cool. Thank you, Hannah. I appreciate that. I'm really excited to be part of the DevFest. Thank you so much. I'm going to share my screen here. It's awesome that we can be on this this platform. So let me see here, share. So now you see, okay. And I'm going to switch over to PowerPoint. So I will start from the beginning here. Yeah, so thank you, Hannah. Thank you for the DevFest organizers. It's a great thing to be a part of these software development conferences that occur, throughout this time of year. And I'm excited to be here to talk about EdgeAI, the next frontier. As Hannah explained, my name's Don Ward. I work at Quicken Loans. I'm a senior software engineer. These days I work in data, actually. I work on data science team. I've worked in mobile. I've switched over to data science. And today I want to, first thing I want to do is let's talk about you. So, here's the thing. When you're doing a presentation like this, especially virtually, presentation 101 is know your audience. So, and that's really rough, during a virtual talk, how do I know who my audience is? So I figured out that, we've most likely got a few devs out there. You can raise your hands if you want. I can't see them, but anyways, we've got data scientists, maybe we've got an embedded developer along the way, or we've got marketing folks. We've got all kinds of group here, a big group here from all walks of life, which is awesome. So what I want, as I was putting together this talk, I figured I'd tailor it towards introducing what EdgeAI is and trying to whet your appetite to get into this. It's because there's a lot of opportunities to get into this field, build some cool stuff, and make our lives easier overall. So let's jump right in. The question I start with when I talk about EdgeAI is, where do your models train and run today? So if you've done a machine learning model and you work in a company, or even if you've done your own models, where do they run? Where do you train those models on your data, and where do you run them? The servers in the cloud. So you use data lakes, data warehouses, whatever, flat files, APIs. Somehow you get your data. Kaggle, data sets. Those are great ways to get your data. And you will build out a model that runs on servers in the cloud, and you'll train your data there. You'll have tons of resources if you need them. Google, Amazon, they all offer even like free Jupyter notebooks with that you can use to train your models, and then most likely you're going to deploy them in the cloud. And again, Google Cloud will allow you to just push one button essentially and deploy your model as an endpoint so that people can use it. So this is kind of where 90% of the world is running right now. Machine learning models are running. Let me ask this: what if we could train and infer closer to the data? So instead of having to collect the data, send it up to the cloud, and run inference like make a decision based on that data, run it through the machine learning model, make a decision. What if we could do it closer to where the data is actually coming in? What happens? What if we could do inference, meaning making predictions using your machine learning model, doing that in real time with no network latency? So you don't have to collect the data, send it up to the cloud via, Wi-Fi, cellular network, whatever it may be. You do it right on device. And what if the model it could take that data and make inferences, make decisions, and then the data never goes to the cloud, so it never leaves device. And this plays into privacy, especially with mobile phones. I never want to send my data. Some data should never leave my phone and go up to the cloud, because who knows who could get it eventually, right? If there's a breach or anything of that sort. So these are some questions I would ask. What if? And the answer is what would satisfy these conditions is Edge AI. This is what Edge AI does. It makes this possible. So what is Edge AI exactly? The really simple version of that is Edge AI is ability for you to run machine learning models on devices that you have right with you, or they're on the edge. They're not on the cloud. They're standalone. Um, they can make decisions right on the spot. That's Edge AI, but they also can send data back to the cloud for analytical purposes later or anything of that sort. So that's really GUMP version of what Edge AI is. So here's some devices that you may be using right now that are doing Edge AI and making machine learning decisions. Obviously, smart home assistants. So your Google or your Nest Hub, your Alexa, they run certain models right on device. One example would be the trigger word. So if you say, "Hey Google," which I think is hopefully it doesn't just trigger my phone. It did. Anyways, that that trigger word there ran right on device. There was a model that ran on your device, either your Google Home or your phone, and determined that you triggered it in real time and decided that, okay, now I have to start listening for your next command. What else? We've got mobile phones. This is a huge market. And this is a classic case of what we call Edge AI, running mobile, machine learning models on your phone for numerous reasons. Big one, privacy. If you go look, Apple's been selling a lot of marketing around Apple that your data never leaves the device, but they're doing cool things with your data on device. Well, Edge AI is how they're doing it. The models are running right on your mobile phone. Then the next one up, and this is something we'll dig into a little more because I think this is a little bit overlooked in terms of from developers' perspective. It's microcontrollers and microprocessors. And if you're interested in getting into this area, there's enormous opportunities here to make some cool stuff. So, but why, again, let's go back. Why would we do Edge AI? Well, one is no network latency, real-time decision-making, no need for a network and so you have that privacy concerns. And the other aspect of it is devices are able to manage themselves smarter. So a classic, immediate place my mind goes is my phone can manage its battery life better. It can know when to allow the radio to call back to, call back home or whatever to update and make updates over the network. It can do things like that. It can learn on the spot and manage its own resources better. A real cool use case that I've heard of was a manufacturer in using Edge AI, a manufacturer of cameras that run on satellites. So these satellites, they circle the Earth all the time, and these cameras are constantly taking pictures, looking for objects of interest. So think of the CIA or FBI, these types of intelligence agencies. They're looking to see if, some country's building something, a military installation or anything of that sort. So this manufacturer of cameras, when they put these cameras up on the satellites, they typically the camera would just typically take a picture every so often, and then not knowing what's in the picture, it would just beam that down to the to Earth, and that's a hit on the battery, right? You have to sending a radio communication down to Earth takes energy. So what they've done and they've started working on is, well, we're going to take a picture of the Earth. Why not run image analysis on it, make a determination whether this image actually fits our criteria, like something interesting there. If it does, send it down to Earth. Otherwise, if you just took a picture of a blank field and or an empty field and there's no one in it, don't wake up the radio, don't waste battery. So real cool applications there. So that's why you'd want to use EdgeAI. Now, what's the size of the industry? Okay, obviously talk about mobile phones, everyone has one. So that's a given. Those things are in your hands, everyone has one. Obviously home automation, your Google Home, your Alexa, they're growing. And smart assistant sales are also growing. And then on top of that, this is what blew me away, is in the realm of microcontrollers, microprocessors, there are 250 of them in the world today. Let me stop and say that again. 250 billion microcontrollers out there today running in the world. They're shipping 28 billion a year. That's how many they shipped in 2018. They project by 2023, they're going to be shipped 38 billion, under 10 billion jump. And all of these devices can be enabled eventually with AI. So huge market there to get some great stuff, technology out into users' hands. So let's jump right in and talk about use cases of mobile. And I'm going to give you some places that you could start, because I can't obviously teach you it all in this amount of time, but use cases for mobile. So obviously, this is one big use case, is image detection or image classification. Any of your filters that maybe you use on Snapchat or Instagram, any of those filters out there are running ML on those images. Here's an image detection model that's detecting faces at an event. And you can see it draws a bounding box around each one. So how could you start using this? So the good news is, it's not that difficult. You don't have to be a data scientist to begin with. If you know how to develop a mobile app, even if you do it natively, you use Flutter, or you might be able to use React Native. I'm not sure about that one, but if you use either native or Flutter, you can definitely tap into ML Kit from what used to be ML Kit from Google. So ML Kit for Firebase was a great library and I'll show you a little bit more what's in there, but that was you could use those models that were already pre-trained. Google had already done all the training for you and made them great. You could use those and figure out use them in your own apps. So that's really awesome opportunity there. In June 2020, they split this actual product out into two separate products, which is cool. ML Kit from Google, and then there's the other one is Firebase ML. And ML Kit from Google is more of if you're not a data scientist, you don't have your own trained model, and you want to add a model, like you have a use case that could use image detection or natural language processing, any sort of that thing, ML Kit will get you there from Google. Whereas Firebase is a little more detailed, but you still can use those type of models on it. So let's jump in. Let me talk a little bit. So these are some of the pre-trained vision models that are available from ML Kit from Google. It's been around, I want to say these models have been out there and available under Firebase, going back, under the ML Kit for Firebase. They've been in that library since about 2018, but you've got barcode scanning, face detection, that's obviously huge, image labeling, object detection and tracking, text recognition, a newer one, digital ink recognition, so recognizing someone's written on paper. And then this last one is and it's interesting because I've been watching them do research on this and post papers, pose detection. So determining how someone is posing in an image. Excuse me. So these are some of the models that you can just basically take off the shelf with about 20 lines of code, get these into your mobile app. There's a few more. There's natural language processing. So you can do things like language ID, determining, going through text and determining what language you've got. On-device translation. So if you've ever used a Google Translate app, they've actually, I think it was 2019 at Google I/O, they actually released this where it was either 2018 or 2019. The years get confused for me, but they released the Google Translate machine learning model so that you could literally build them in your own app. And the interesting thing about this is it's actually a two-part transformation. So if you're going from French to say Spanish, you would grab the French to English translator and then the English to Spanish translator, and that's how you would do it, and pass your text through there. And then Smart Reply, if you use Gmail and that you're filling out you're writing an email and it suggests things, well, Smart Reply now is available for you to use in your apps. So this is ML Kit for Google. Pretty easy to grab those models, use them in your app, and there's lots of examples. The other one is Firebase ML, which I've used personally. I've used both of these, but and the reason I would use this one is we've used it, or I've used it in cases where we had custom-made models that we built like Quicken. We've used them. And how do I want to run that on a mobile device? So Firebase ML will allow you to take your model that have been trained in TensorFlow, get it into TensorFlow Lite, convert it down to TensorFlow Lite, and because not all operations that TensorFlow uses are supported on mobile devices, and allow you to actually push it out to your device and run it as you need to. I've done it with Flutter. You do have to use a platform-specific channel to actually communicate with your model, depending on how you integrate it, but definitely doable. And to that point, here's a little. I taught this workshop a little earlier this year, when we could meet in person, which, and you can see it running here on the side here. It's basically a simple face detection app where you detect faces from a gallery. You go in, you grab the Mona Lisa, and it draws a mustache on her. So here's the thing. If you go to that GitHub repo, and we'll have the slides up later, I led this walkthrough for an hour with 100 people where we basically coded this up in Flutter, and it was step by step. You can grab the code for step one and say, okay, here's step one, do this. Here's the code for step one. Drop that into your IDE. Maybe you can run it, maybe not, but you understand what's going on. Step two, add a little more code, and so on and so forth. So we walk, I believe it's about 30 steps, but end up with an app that can do this. So if you want to check that out, it's on my GitHub, and there is a slide deck there too. So one way you can get started with using any of these machine learning models. And in this case, we actually use I'm going to go back here, see if it will allow me. We use the face detection pre-trained model from Google that's in ML Kit. So wasn't training our own models to recognize faces, but we used it in this case. So continuing on, let's talk about microcontrollers and microprocessors. So how do they leverage ML? I'm just checking, do a time check here. There's a lot of cool ways that these devices leverage ML. Obviously, image is one. This is a snapshot of one of the NVIDIA's Nano Jetsons devices running in real time and detecting people in video. They obviously can also they have, well, the difference, I think the big difference between them and mobile is one, the size. So for instance, your Fitbit, we'll talk about that a little more, but some of the processors that you can run ML on now, the microprocessors, are the size that they would fit in a Fitbit or a smart assist, a smartwatch. So you've got that size aspect. The other part of that is you've got a more wider range of sensors. So the NVIDIA board that we'll talk about a little later is able to do machine learning and run machine learning models on 8 video feeds at once in real time at 30 frames per second. So a lot more horsepower there. So they're not as geared towards a mobile. They're not a mobile phone, but they've got more capabilities in some respects. But they do have some other restrictions. The other thing about these, so a lot of these devices is you will get sensor data quicker than you would on a mobile phone. Whereas if your app is on a mobile phone, you're really at the mercy of how frequently does the if you're looking for real-time data to come in, how often does the operating system provide you that data? Versus a real-time device, you can get that data as fast as it can read from the sensor. So, there's a different realm here, but there's a lot of opportunity. So I just want to give you an overview, where you could get started if you were to, so jump in. And this is where I've worked with some of these ones too. So in the microcontroller realm, microcontrollers, for those not familiar, they have more horsepower. They're more of a full-blown computer essentially on a small board. And I think there's two real big ones here. I know Intel is also along in this round too, but I'm not going to share stuff that I don't know exactly a lot about, but I do know they're on it. So these three boards here, we've got the Jetson, the first two on the left there, the Jetson series boards are from NVIDIA. NVIDIA has huge investment into machine learning, edge AI, because of their GPUs. They're so powerful, and machine learning models love to, they're made to be run on GPUs because of the parallel processing that can go on there. So you've got the first one, that Jetson Nano 2 GB developer kit. So this is a developer kit. This is a kit that you would take home, you'd buy it. This kit is actually about $60. You buy it from NVIDIA right on their site. It's got 2 gigs of memory. It's able to process one video feed in real time, and it's got a Ubuntu running on it. You literally take it home as a developer, develop your use case on it, and if you actually were to go to market, you can actually unscrew the processor that's sitting under that big, huge heatsink there, and actually, move it to a prototyping board for whatever your application would be. So it's really cool what you can do with that 2 GB developer kit. Now, its bigger brother, which came out first actually, is the Nano developer kit in the middle there. Has more RAM, 4 gigs. This one can process 8 video feeds in real time. That's $100 board there. And I want you to notice how big the heat sinks on these things are. When you're training a model, I've trained models with this thing, these boards get hot. I mean, they're chugging away, and they're processing there's a lot of processing power on there. I also know that people, when they first came out with this board, there was a run on them. A lot of them sold out because people were buying them to use for their own home streaming system, because for $99 you got a Ubuntu system with HDMI. I think it's got 2 HDMI. It's got a number of USB. It's got LAN LAN connector, and you do have to add a Wi-Fi, although, which is easy to add. And then from Google's perspective, they got into this more. From what I've seen in the 2019 at Google I/O, they released the Edge TPU boards. If you're not familiar with TPU, Google came up with their own board to run machine learning in their data centers called the TPU board, TensorFlow. It's either Tensor Processing Unit, that's what it's called. That's what TPU stands for. And what they've done is they've called these boards the TPU at the edge. The boards are made by Coral for Google, and that's one of them. They're a little more pricey. This one's about $130 on their site. You can buy it. It's a developer board again. This one actually has a fan, which is interesting. But what I have found is the Google product, the Coral board, does walk you through and get you started. Like there's more examples that you can just jump in and work with. So anyways, these are some of the microcontroller realm. And if you did want to get started, there's there's 2 ways I think that are great ways to get started. One is AWS, or sorry, not SageMaker, AWS Deep Razor. If you haven't tried that or looked into it, that's one way of getting started. You're not working necessarily with a high-end microprocessor, but it does teach the basics of reinforcement learning and how to race autonomous cars that learn the course, and you get some of that. And then if you want to do a little more do-it-yourself path, I have some friends that do this. I haven't done it myself. I don't have so much time in the day, but this NVIDIA has their autonomous car races, which is really cool, because what you're doing is you're taking these nano developer boards and you're mounting them on your own car frame. And there's some rules around it, but you're allowed to, you're training the car to run a course using whatever machine learning models and models you want to use. So not necessarily restricted to reinforcement learning. You can do what makes sense for you. It does take a little bit more, DIW, or sorry, do it yourself, but really cool stuff. So let's jump over to the microprocessor realm. These are some of the ideas. Where you get into it. I don't know if a Raspberry Pi necessarily qualifies as a microprocessor, but I lumped it in here. It is it runs Linux. This is a Raspberry Pi 3B plus, I think. Anyways, and you can do a lot of cool stuff. Just run machine learning models on it. The other cool thing is, if I go back, this Coral board here that Google produces with the Edge TPU on it, they actually make a USB version of it that will fit on a Raspberry Pi that works with a Raspberry Pi. So you could literally have a Raspberry Pi that gathers the data like from a camera, offload the processing, the machine learning processing or training to the Edge TPU unit, let it get all warm and run it as hard as it can, and then prevent the data back to the Raspberry Pi. So that's cool. The other place, and then we go even another step down from the Raspberry Pi, which you see here, and where an area that I've been doing quite a bit of work recently in is on this area called TinyML. And so TinyML is taking, in my opinion, it's literally taking machine learning to the very extreme edge. The devices that have the fewest resources, but are the most, there's the most of them out there. So the two devices I'm showing here, there's more of them out there that will run, but both of these devices will run TensorFlow models. You can train a model in TensorFlow. You can convert it using the TensorFlow Lite converter. You can actually get those models to run on these two devices, the SparkFun Edge or the Arduino 33 BLE Sense, which actually that's, I missed it, should be 33 nano BLE Sense. But these devices have limited resources. They're meant to be powered by batteries. For instance, that SparkFun Edge device there can be powered by the side you don't see here, but on the other side, it actually has a holder for a coin battery. They can run for months on end. They run in continually. They don't stop. They do one thing and they do it well, and they have more access to more sensors out there than maybe some of the others would have. So I want to jump in and talk a little more about these, but the one thing I do want to share is, so to me, it's an interesting evolution because, machine learning came along, data science, training models, and like making decisions based off of that all came along. And then someone said, well, how do I move my model onto one of these super small devices? How do I get that running? And it's interesting because it was a Googler who came out with a SparkFun Edge. He worked with SparkFun, and back in it would have been 2019 at Google I/O, they presented this SparkFun Edge board, and they showed it off, and they showed it at the TensorFlow Summit. And the idea, the whole thinking behind this was, why this device, the model that they trained initially, is able to detect the words yes or no. So when you say yes, it would know, oh, someone just said yes, or no, and it'd say no, okay, or any other word, it would say, okay, then they didn't say yes or no. So that's what that model is capable of determining. And what drove that decision? What drove the development of that? Well, the engineer at the time, his name's Pete Warden, was looking at, the story as it goes is, he was looking at mobile phones, and the trigger were like, what triggers your mobile phone to wake up? If you say, okay, Google, my phone just woke up. What triggers it? Well, for the longest time, they were using customized chips that used a lot of battery, and they were looking at frequencies and figuring that out. And then he thought, well, it'd be really cool. Machine learning is more accurate. What happens if I could put that, we could get that running on a chip? So when they presented this, and they presented that model where it detects yes or no from a speech, a stream of speech, They presented it and they showed that model, they had shrunk it down to actually 20 kilobits, and they got it working on this device, which is amazing. So that was the first device actually that I know of that you could run TensorFlow on in that small a form factor. And then this new one, there's another one, it's the Arduino. And if anyone's familiar with microprocessors from Arduino, they definitely have they make it very easy to get started and run with. So I'm going to jump in right now and show you, here's some of the things you can do with just those two processors on the right there. Well, actually the Raspberry Pi 2. Speech recognition, which we just talked about, yes or no. Trigger word detection, motion detection. So you hook a camera up, or they actually have motion sensors, and they can detect what kind of motion it was. They also have accelerometers and gyro, which I'll show you in a little bit when we do the demo, that can detect when the device was moved and actually determine, looking at the data coming in from the accelerometer, say, I moved in this direction, which is really neat. And then human detection. This came along recently. It's not been that long that I've seen, but we're able to get models to run on these smaller devices using to recognize humans and other things in images. So some considerations, just to give you an idea of what you're dealing with here. You've got this model that's trained to do speech analytics, and it's trained to run in in the cloud on a server. It's got multiple cores. It's got infinite amount of memory if it needs it. It does it, and it can run with floating point data, which is what you typically train a machine learning model with. These devices don't really like to work too much with floating point data. So this concept of quantization of models was actually kind of a big breakthrough when they could do this, where they took these the data that's in the machine learning model, the weights and all the biases and everything, all those hyperparameters, and they were able to take them from floating point and scale them to integers. These devices are made for that. They can crunch those integers much easier than the floating point, and that led to them being, engineers being able to shrink these models down to 20K. The other consideration, noisy data. Your raw sensor data is coming in. You have to do some sort of averaging or smoothing. Finite amount of memory on these devices. They don't have a lot. 20K is what they fitted on in that SmartFun Edge device. Memory allocation, how do you allocate your memory is important because these devices, the way they're made is they're real-time operating systems. You don't allocate memory on the fly. When they start up, all the memory has been allocated. That way there you don't run into issues when they run continuously for years. And that's what another consideration you have to make. So let me see if I can do a demo here, show you a little bit of what we've got and where you would want to get started. So let me just look at my notes here. I'm doing pretty decent on time. Okay, so as I said, the first place I would start, and I did start, is with if you look in TensorFlow, you'll see this is one of probably the best supported machine learning libraries out there for these devices, and they're furthest ahead as far as I'm concerned. TensorFlow Lite for microcontrollers, you can find this, in the URL. They talk about why it's important. You do everything in C++, although you can, that can be abstracted away a little bit. Here's some of the boards that you can use, and there's a few examples here. So hello world, speech detection, motion detection, and person detection. So I would start with this, but then if you're interested, it's interesting to me, what I found was if you actually go to the GitHub repo for TensorFlow and you drill down to TensorFlow Lite and then into the micro directory, here's all of this work that's been done on these so far. So here's all these libraries. So I jumped into this and I started building, and I kind of found a better way, honestly. As a beginner, what I would suggest you do is I would suggest you go and invest. You're going to spend $30, get one of these, an Arduino Nano 33 BLE Sense. It's got a ton of sensors on it. It's got Bluetooth for one. It's got 9 axes inertial sensors, humidity, temperature, barometric pressure, microphone, gesture, proximity, light, color, sensors. And the reason I would say go grab one of these is the Arduino development experience, the way that they structure things is easier for beginners to get started. So once you get that, what I would do is, check out their site. Obviously, it's got a good get starting. They do have an Arduino desktop IDE. If you haven't used it, it's okay. It's not the best, but it gets you started. And the nice thing about it is, if you look and if you actually went through the guide in TensorFlow to get started with one of these devices and build a model, you're linking in a lot of libraries from different directories, and it really can confuse you if you're a beginner. Whereas the Arduino examples, when you look at the code, it's all in one file. So Arduino has pulled it in and made it so that everything is in one file. It's a lot easier to understand to get started. If you were to jump in, what I would, first thing you do is actually walk you through, here's one that I'm going to show you, gesture recognition. So let me show you what this builds you. If this is a simple example here, I'm going to jump over to VS Code, hopefully. Here's an example of when I talk about simple, let me just hide my samples here. Simple files, there's one main file that has all of your code in it, and there's two header files, which is actually just your data. So interesting enough, this is what the model looks like when I wrote it up on a microprocessor. It's just raw, unsigned character data that you would load into your model, right into memory, and run your machine learning model against that. So very simple, like the one file, it's not, if you look at my mini map, it's not too large, and that's useful. That's easy as a beginner. What does this do? Let me see if I can show you here. So I don't know if you can see, but this is the device. I can't see my camera right now, so I'm assuming that you can see my microcontroller. And if I move it, if you look at the output right here in the terminal, I'm running that, and if I move it, say, left to right, whoops, it said, oh, 94% accuracy that it determined that we moved left to right. And then I just jiggled it a little bit more. If I move right to left, it comes up, oh, 78% accuracy that we moved right to left. And I can try top to bottom. This one's not as accurate. Bottom to top, okay, 61%. See, top to bottom. Okay, so it's not perfect, but gives you an idea of what you can do. Let's jump back to so how would you do this? So they have you start with a Jupyter notebook, which is a standard tool to use for machine learning. And you could walk through this whole tutorial where they show you how to sample the data from the device, collect the data, train the model, which I've done. This is a sample they give you. I've done a modified this for my own using and running this on Google Colab. Run the whole everything through this machine learning model, train it. Here's, you can see all the training and the losses, and excuse me, just zoom here, and actually plot it out. And then at the end, what they have you do is they give you actually the tool to actually just export that model into this file here that I showed you, this model.h, which, just one moment here, I gotta, anyway, no, where does it go? Shrink things down. Yes, right here, so up top. So you can go through the Jupyter notebook, train your model on real data, convert it down using TensorFlow Lite, drop it into your app, and basically run it on your device as you need to do. So pretty simple, but if you do need to, you want to get started, I've dropped the links here. It's in my GitHub gist. You can go to this bit.ly, and it's got a bunch of these, the links to some of these resources. Oh, it's not this one. It's, I don't have it. Oh, here it is. Useful links to get started. One thing I will say is, and if you are interested and you want to go a little deeper, this book here, Tiny ML by Pete Warden and Daniel, I can't say his name properly, but anyways, this is a great book that walks you through Tiny ML too. So with that, I hope I got you interested in ML, EdgeAI, what you can do with it. It's really exciting stuff. tons of opportunity here in this area, and I'd say go build. So thank you, and that's all I've got today.
Okay. Awesome. Thank you so much, Don. That was an amazing talk. I guess we'll kind of segue into some questions that people might have about your talk and machine learning in general. So if anyone does, feel free to use the Q&A channel off to the right-hand side for any of your questions. So we'll give it maybe like a couple of minutes to see if people have questions for you. Let's see here. All right, cool. Well, while we're waiting, I do have a question. So machine learning is not my forte, but if somebody were to want to get started, what are some good places to hit up for information, like whether textbooks or videos to watch to kind of get a better understanding of how that all works?
Yeah, that's a great question. And I was exactly 2 years ago, I was exact same spot. Didn't know a thing about it, honestly. I took a Coursera course. There is a free Coursera course on machine learning. It isn't too intense. There is a little bit of math, but then again, machine learning does involve math. But the concepts are there. It's taught by Andrew Ng. He's like a notable figure in machine learning world. He's one of the co-founders of Coursera and one of the former heads of Google Brain team, and worked at Alibaba, led their machine learning model. He has a really good way in his Coursera course to bring it down a level so that anyone can understand what he's talking about. It's a free course. And then if you go from there, there's an actual either further deep learning specialty where you learn to build larger models.
Mm-hmm.
But I will say, to do edge AI, you don't need to necessarily know the machine learning, like how to train a model or anything. You can take these off the shelf and run them in your mobile apps, or even play around with microcontrollers like I've been doing.
Okay, awesome. All right. Well,
So we
I
got
think that kind of helps out with, if you were new to machine learning, kind of
yeah.
those resources that Dawn has suggested. It looks like we do have a couple of questions now in the chat. So Jeff asks, which of the devices you suggested should people start with?
So the Arduino, the Nano, the BLE Sense, like that's an excellent device to start with. Super easy. The learning curve's nice. And the nice thing about it is you'll see results right away. So that's like, if you're learning something, you want to see results. You don't want to be learning, and then I don't see any, like, what am I doing this for? So that one there is definitely, if you're looking for microcontrollers, if you're looking to do anything with mobile, you can check out my Git repo, that one I shared about developing a Flutter app. But even with Flutter, you can definitely get machine learning models running really quick, and you can spin up something quick in Flutter, obviously. What else we got? What online groups are you a part of to chat and build with as we develop our skills? I mean, in terms of Arduino, like the Arduino stuff, what I did is there's a practice called 100 Days of Code. It's a program where you literally dive into something for 100 days. I started it, I'm going to say it was earlier this year, and I did it just with Arduinos. And every day I had spent 1 hour coding. And some days you just like bang your head against the wall. Oh, I can't figure anything else. The thing is, you report out what you did, you tweet it, and you'd be surprised the number of people that reach out to you and say, I could help you here, or I know this. So that was one way I learned, anyways. In your sample, what sensors were used to train it? How do you create the data for training? So that's a good question. There's an accelerometer and a gyroscope on this device here, on the processor itself, and that's what I was using actually to train it. So you sample the data yourself. You actually run it in a serial monitor, which actually collects the data and dumps it out on your computer. And then you can just that's your data. You bring it in, you can do with it what you want. What cloud tools have you used for model training? So I'm getting into SageMaker a little these days. I have used Google Colab, as I showed, and that's a great way to use Jupyter notebooks. And that's, those are what I've done. There are obviously auto ML tools out there that you can use too, if you want. Let's see, hopefully that answers that. I'm trying to get, how do you see onboard AI differentiate from firmware? Is it more advanced firmware? Oh, okay, so I think in terms of microcontrollers, you could term onboard AI as its finished product that goes out to the consumer as firmware. You could. I mean, we're at the point where we're just developing the app that would run on the microcontroller. So firmware, you can call it firmware. Uh, some people would call the operating system for the microcontroller firmware. So it's just a little differentiation there, but Coro USB TPU plugs into any USB. That's a great place to start. Exactly. Yes. That's if you want to use the TPU, the Coral boards from Google, I think they're like $50 too. They're not that much. They do get hot. All of those Nano Jetsons, those Edge TPU devices, you can tell they're really struggling with the heat management because those things really warm up if you start doing some image analysis or anything of that sort on. Let's continue on here. What are great repositories of projects out there already complete that I can look at to learn from? I mean, honestly, TensorFlow has a great, you know, their tutorials. I would just start from scratch to tell you the truth. If you want to learn machine learning, as I said, the Arduino, I like how they've structured the learning and the projects because it's one file. I have a hard time keeping track of like, I'm bringing in this variable from this file and this variable from here, and keep all that in my mind when I'm just learning the concepts. It doesn't work for me. That book, Tiny ML, it's a really good book too. If you do want to look into it, I've read half of it so far. Life gets in the way. What else? What do you know now that you wish you knew sooner? That's a good question.
Yeah, that's a good question.
I think, darn it, that's a good, yeah. I think in terms of, I got some of the things I thought I could do with this device, you know, you, I think some of my ideas initially when I tried some of my projects and I ran into a wall, I think I had to ease into them a little easier because when you're working with these, like the accelerometer and gyrometer on this thing, they're sampling very quickly. So you have to, like every time I showed you where it was moving left to right, it was doing 120 samples in that short amount of time. And it was running that through a machine learning model and say, oh, the data looks like you just moved from right to left. That's the pattern I saw in the data. So it's marrying what I know about computer science as a developer with the fastness and the hardware, I guess. I have not used Data Studio, something I guess I could look into. Are you constantly part of any platform like Discord? You follow quite often, which helped shape your career in the tech world initially and still. To be honest, not terribly. I mean, I'm on LinkedIn, and I do watch Tech Meme a lot to see what's going on in the tech world. But other than that, if you're learning to get into the tech world, build something. Let's say that much and show it off. Hopefully that helps. That's a good question. A lot of people are trying to determine how to break into tech, and I would say build something and be able to show it. If you go to an interview and you show that you built something and it's working, you're going to knock their socks off right there. They're just going to be like, wow, like they actually took the time to do this, because a lot of people talk, but having a device that actually does something, or an RC car that runs on by itself, wow, not too many people doing that. So
Yep.
hopefully that helps.
Very, very true. Okay, well, it looks like I think that's all the questions. We have just a
Cool.
few more minutes until our next talk. But again, thank you so much, Dawn. That was a wonderful, amazing talk.
Thank you. appreciate it.
Yeah, you coming on and telling us a little bit more about machine learning and what you do as well. So yeah,
Cool.
from here, I guess, feel free to go out onto the floor, socialize for a couple of minutes before we begin our next talk at 1. So yeah, there we go. All right, thanks, Lon.
Thank you. Have a great day. Bye.
You too. Bye.